Alright, so I want to go through this problem related to the lac operon. And this was on the problem set for Module 7 and under prokaryotic problem set. So what I've done on the board is reproduce the grid that's in the problem. And then on the left side here, various information about either the lac repressor or the lac operator related to the different genotypes here. All right, so this has genotypes on the left, and then we're looking for, is there expression of beta-galactosidase? And remember, beta-galactosidase is from the LAC-Z gene. And is there expression of lactose permease? And remember, that's from the LAC-Y gene. And for each of them, we're looking for expression in media with lactose or without. With or without, okay? So we're starting with just the wild type genotype, wild type alleles for repressor, operator, LAC-Z, and LAC-Y. Do you see LAC-Z expression in media with lactose? Yes, lactose is going to induce expression, right? Do you see expression of LAC-Z in media without lactose? No, it's inducible. Like all catabolite regulated genes, inducible expression. So that's a minus. And it's going to be the same for lac permease, right? Because it's part of the same operon. So present with lactose, absent without lactose. Okay. How about in this case, repressor positive, operator positive, LAC-Z negative, LAC-Y positive. So LAC-Z negative indicates a null allele of the LAC-Z gene. So in that case, you can't get expression of beta-galactosidase with or without lactose because the gene itself is mutated. For LAC-Y though, it's still going to be inducible because it's hooked up to this wild type operator. So present with lactose, absent without. And this genotype here is similar to this one, except it's LAC-Y that's mutant. And so you won't have expression of lactose permease, it's a null allele, but you will have inducible expression of lactose beta-galactosidase. All right, in this example now, the mutation is in the lac repressor gene. And the repressor is a null allele, or it's at least not functional. So what happens is, in the lac minus, if it's not a null, it still produces a protein. The mutation is in the site that binds to the operator. For the wild type repressor, the site that binds to the operator is going to fit into the wild type operator, right? It's going to bind onto it. In the lac minus, this repressor is not capable of binding to the wild type operator. So either the repressor is absent or not able to bind to the operator. If it can't bind to the operator, then this operon can't be shut off. It's going to result in constitutive expression. And that's going to be true in the presence or the absence of lactose because repressor can never bind. Okay? How about this super repressor allele? In the super repressor allele, the repressor is mutated not on the operator binding site, but in the inducer binding site. So when lactose is present, it can't bind to the repressor and it can't pull it off. So this repressor is always going to be bound to the operator, and that's true in the presence or absence of lactose. Even when lactose is present, can't bind, can't change its shape, like in wild type, right? Wild type repressor. In the presence of lactose, lactose binds, repressor changes shape, and this repressor can't bind to the operator. Super repressor never changes shape. So these are always going to be shut off. The super repressor never can be pulled off the operator. Finally, this genotype is an operator constitutive mutation. In an operator constitutive mutation, the repressor binding site, the sequence of the operator is mutated. And in this mutated version, it's not capable of binding to the repressor. So this can also never be this can't be shut off because the repressor can't bind. Constitutive expression of both LAC-Z and LAC-Y in the operator constitutive mutation. Okay? So that's how that answer came about.